Welcome to Shoal Maths, the magic behind the math. Hopefully I can help you by showing you what you never knew you needed to know. Today we're going to be looking at what to do with your sum and difference formulas for sine and cosine. Really the sum and difference. So this first part's pretty cool. Well, if you already know sine of a sum of two angles, you can figure out sine of a double angle. Well, if you just put in x for your two angles, you'll have x plus x is 2x, so we end up with sine of 2x. I'm writing pretty fast here, but you can see, well, okay, so sine of the first angle, cosine of the second angle, cosine of the first angle, sine of the second angle, we end up with sine of a double angle is 2 sine cosine. You can do the same thing with cosine of a sum of angles. If you want now, you can pause the video, try to put in cosine of, x plus x, and see if you can simplify correctly. Here it comes in 3, 2, 1, go! Oh, there we go. It's like a race. Okay, so then you get cosine of 2x, or a double angle, is cosine squared minus sine squared. And that might not seem like a big deal. There's a reason I did cosine of a double angle second. This formula, if you know it, and obviously you know our formula for cosine of a double angle, if you know cosine of a sum of angles, you can create quite a few other formulas, which is where most of this video is going to go. So I think you already know the main Pythagorean identity. Sine squared plus cosine squared of the same angle is 1. And so you could see I'm pointing here. We're going to replace sine squared. Well, let's think about this. Sine squared would be, subtract cosine from both sides, 1 minus cosine squared. So that's what I replace sine squared with. And a little bit of algebra, and we have 2 cosine squared minus 1 is equal to cosine of 2x. So now it's time to rearrange. Pretty easy algebra here. We're just solving for this cosine squared. We're actually getting to our power reducing formula for cosine. So there you go, pretty easily. All we had to do was add 1 to both sides, divide by 2. So now if you have cosine squared and maybe you don't need that, you want to reduce the power. Well, if you want to reduce the power, you're probably thinking calculus. You want to take an easy derivative rather than a harder one. Here is what you're going to do. So you can guess what's coming up next. Maybe you can't. We are going to find the other power reducing formula, and that's sine squared. So how are we going to get sine squared? Well, we do almost the same thing. We do start with cosine of 2x is cosine squared plus sine squared, but we're going to replace this cosine squared with, well, solving for cosine squared would be 1 minus our sine squared. From there, it's almost the exact same process. You can see 1 minus 2 sine squared is equal to cosine of 2x. Oh, made a mistake. You got to subtract from both sides. So all we had to do, it depends how you look at it. We could add 2 sine squared to both sides, then subtract cosine of 2x from both sides of the equation. And then we need to divide by 2 to get rid of here. So now you have your 2 power reducing formulas. But more powerful, you can create these 2 power reducing formulas if you can go back to cosine of a double angle, which comes from cosine of just an angle plus an angle, which I think you know by now. Well, what can we do now? Well, we keep rearranging. So I don't know about you. I like having cosine squared on the left, sine squared on the left. That feels like what I'm solving for. What we're working towards now is the half angle formulas for sine and cosine. Now you'll notice we took the square root of both sides, but be very careful here. This plus minus isn't the normal plus minus. So we're working towards cosine of a half an angle. You have to use, kind of based on the unit circle and where you know your angle is going to be, you have to use the correct positive or negative sign. If your cosine is in the first or fourth quadrant, you take the positive square root. If your cosine is going to be of an angle in the second or third quadrant, we'll use the negative square root. Same conversation for sine of half an angle, and it'll look better here in a minute. for sine of half an angle, you have to choose, okay, so my angle is going to end up being in, well, the first or the second quadrant. For sine is going to give us a positive square root that we'll keep. And if our angle is going to be in the third or fourth quadrant, well, sine is going to give us a negative value, so we'd choose the negative square root. So what we're doing now is, well, we're doing cosine of half of an angle we know. Back here, we actually have the same formula, but the difference is, well, this doesn't look like half an angle I know, so we replace x with x over 2. This looks like half an angle I know. So with this, let's say you knew cosine of 45 degrees. Well, you're going to end up with something like that over here, cosine of 45 degrees. You could take cosine of 22.5 degrees, which I bet you can't do off the top of your head. So now that's the half angle formula for cosine. So cosine of half an angle I know is, well, you have to choose the correct sign based on the quadrant of this angle. And 1 plus cosine of the angle you do know, which is twice this input angle. Again, we're paused here. You can finish off the math for sine of half an angle. I'm sure you know where it's going next. There you go. And you get a nice, pretty sine of half an angle I know is, there's a lot of symmetry here. 1 minus cosine, 1 plus cosine, all divided by 2 inside the radical. That's going to be pretty easy to remember, but good news, you don't need to remember these. You can create these out of sine squared. Well, I guess that's not sine squared. You can create these out of the double angle for cosine, cosine squared minus sine squared, and your Pythagorean identity. Thanks for watching. If there are other things you want to see, please leave them in the comments.